With your permission, the session is getting recorded, and I'll ensure that you'll all get this recording today or in a couple of days of time. So today we're going to get started with getting to know the Kubernetes. We'll begin with the first section, Introduction to Kubernetes. In this section, I'm going to talk about what Kubernetes is, why would somebody use Kubernetes, the we get the high level understanding of the Kubernetes architecture, and we take a look at those some of the Kubernetes architecture components. We'll also get familiar with some of the terminologies of the Kubernetes, and we understand the need of knowing the YAML for the configuration information in Kubernetes. I would request one of you to admit somebody waiting in the lobby so that I don't need to switch between the windows. So Kubernetes basically is an open source platform which is designed to automate the deployment, which allow you to scale up and down your application and manage your applications. With the help of Kubernetes, you can deploy applications quickly and predictably. You can also scale your applications up and down on the fly. Also, you can not only scale manually, also you can automatically scale with the help of HPA, which is horizontal pod autoscaler. If you come up with a new version of your application without bringing the application down, you can roll out the newer feature seamlessly. You can also limit on the how much of the hardware resource each application or a project or a namespace can utilize from the Kubernetes. At bare minimum, we can expect a Kubernetes to schedule and run our application containers on a cluster of physical or virtual machines. So Kubernetes at bare minimum schedules your application to run on one of the container engine, which is part of the Kubernetes cluster, without we having to manually pick and choose. It is the kube scheduler, which is one of the Kubernetes component, which provides that functionality. This is what we can expect at bare minimum with Kubernetes. Some of the features that we expect from the Kubernetes to satisfy the common needs for an application to be running in production is Kubernetes provides the centralized storage system. You can have many different storages integrated with Kubernetes to persist your application data within Kubernetes. Kubernetes allow you to secure your sensitive information with the help of Kubernetes secret service. The sensitive information includes such as the passwords, the SSH key pairs, the tokens. Instead of you hard code those sensitive information as part of your container image or put it in the YAML or JSON configuration manifest, Kubernetes provides you the secret service. If there is some non-sensitive data which you want to distribute or make available to the application, you also can leverage the config maps. Kubernetes take care of ensuring your application is healthy and available all time. Kubernetes allow you to provide provide the information about how many replicas of your application you want to have, and it ensures the requested number of replicas of your application instances are running at any given point of time. Kubernetes has a feature of HPA, which is horizontal pod auto scaling, where it will allow you to have the statistics set such as memory usage or CPU usage. Based on that, automatically the replicas of your application or pods can be scaled up and scaled down. Kubernetes take care of naming your services that you want to run in Kubernetes and help discover them with the help of core DNS or kubedns in Kubernetes. Kubernetes provides the load balancing capability with one of its architecture component, kubeproxy. With the help of deployment in Kubernetes, you can roll out the new version of your applications. It also has a basic level of monitoring and logging facility. But of course, if you're looking for an enterprise grade, you might want to integrate a third party monitoring and logging tools with the Kubernetes as it supports integration of such tools. Kubernetes allow you also to debug your application if there is anything, and Kubernetes take care of authentication and authorization. You can also integrate LDAP, ADDS if you wanted to integrate with Kubernetes. Any other authentication and authorization mechanism that you want to integrate. These are some of the features that we would need for us to run an applications in production. So Kubernetes has most of those enterprise level features, but there are some which still missing. Of course, you can integrate them to be leveraged within Kubernetes. The Kubernetes name originates from the Greek meaning helpsman or pilot. Sometimes we also get to see or hear about K8s, which is abbreviation derived by replacing the 8 letters between the K and S, which is why you get to see or read about K8s. Kubernetes is portable, extensible, and self-healing. Let's understand why do we call Kubernetes as portable, extensible, and provides a self-healing capability. We call it portable because we can run Kubernetes cluster on physical or bare metal servers, a virtualized servers, or on a private or public cloud. Of course, we can also run on a hybrid cloud, meaning having to run some part of the components on the on premises and some part of the components to run on the one of the cloud provider. Or we can also have the Kubernetes running on multi-cloud. Some components of Kubernetes running on Azure, some are running on the AWS. Even that is also doable. So Kubernetes is portable, can be installed and configured on any of the infrastructure. Kubernetes is extensible because the Kubernetes architecture is modular. You can pick and choose what you need. You don't have to install all of the components of Kubernetes. There are some core components and there are optional components. Kubernetes is pluggable as it supports integration of third-party storages, third-party network solutions, third-party monitoring and logging capabilities. So it's Kubernetes is pluggable. You can have the plugins installed to leverage those third-party solutions into Kubernetes. Kubernetes is also hookable, meaning if you already have some existing solution and you want to integrate Kubernetes with that solution, you also can do that. Kubernetes is composable. You can come up with your own version of Kubernetes, making few adjustments or changes to the Kubernetes as it is composable. Kubernetes provides a self-healing mechanism. So Kubernetes take care of automatically deciding on where your application should run, on which node of the cluster. If one of your instance or one of the application instance fails, Kubernetes is responsible for automatically restarting that instance of your application or a replica. Kubernetes take care of ensuring the requested number of replicas are maintained. If needed, it can also auto scale based on the HPA or metrics such as memory utilization and the CPU utilization. But there are few of the missing features that we need to be clear with that Kubernetes currently does not have built in. Kubernetes does not have a middleware, a data processing framework, a databases like MySQL, MariaDB, nor the cluster storage like SF. But these are something that you can install on top of the vanilla Kubernetes to be enterprise ready. So Kubernetes does not have a click to deploy service marketplace. You can integrate the Helm to make it a click to deploy such kind of a service. I see some of the hands raised. Like I said, I will take up the questions end of the session. Please hold your questions. So Kubernetes does not have the source code or build your application on the fly. Kubernetes does not dictate the monitoring and logging capability by default. So all this can be integrated with Kubernetes. I'm talking about the vanilla version of Kubernetes, but very soon you'll get to see all of these features are some of the competitive features as part of the Kubernetes. So Kubernetes is in the category of infrastructure as a service. Kubernetes is not a platform as a service. There are other tools which leverages Kubernetes and provide you the platforms such as OpenShift, Rancher. There are many other tools which are platform as a service, but Kubernetes comes in the category of infrastructure as a service, which provides the containerized infrastructure for our application to be deployed. So let's get into the high level architecture of Kubernetes. So Kubernetes mainly has a master and a worker nodes. So we as a administrator or a developer or a user, we run the kubectl command. Those commands are sent to the Kubernetes master. There is the kube API server, which receives those instructions either as a command line or as those commands can be in an imperative method or as a declarative method. Declarative maybe in the form of JSON file or a YAML file. And you can have multiple worker nodes or minions, the other name for the worker nodes, which is where we will run our applications, or Kubernetes master runs those applications behalf of you. So at high level, in Kubernetes cluster, we have the master and the worker nodes. On the worker nodes, we run a pod. If we have not yet discussed on what pod is, to have a basic understanding, if you attended my yesterday session, I spoke about container. So pod is a collection of one or more containers because pod is the smallest deployable unit in the Kubernetes. Kubernetes does not directly identify the containers or does not directly deal with the containers. Instead, it deals with the pod. You can think pod is just a wrapper around the containers. We'll talk about the pod later in the discussion. So pod is just a group of containers related to each other and they share the namespace. And just like containers are ephemeral, meaning the data that you store inside the container is temporary, the pods are also ephemeral because behind the pod, it's nothing but a container. I can just give a simple example. A pod can be a collection of one or more containers. One of the use case, I want to have the MySQL database container running as well as WordPress web server running within a single pod. Just like if you are aware of, there is the Docker Compose, which allow you to run multi-tier applications, right? So a pod is a group of containers, one container for MySQL, one container for WordPress, and you want them to be running as part of a single pod. So in Kubernetes, the pod is nothing but collection of containers that are co-scheduled as well as co-located. In a single node of the Kubernetes cluster, you can run multiple pods. In a single pod, you can have multiple containers. But these containers, part of a single pod, cannot split across multiple nodes, or they must be running in the same node. But for an application, you can have more than one pod, and these pods can run on a same node or can be running on a different node. In Kubernetes, we use kubectl command to manage the resources within the Kubernetes cluster. You want to create, delete, or retrieve the information about those Kubernetes resources. So if I just connect to my one of the Kubernetes cluster, which I already have deployed, today in this demonstration, you're also going to learn how to deploy a Kubernetes cluster. Just to give you some understanding, I'm connecting to the cluster which is already deployed. Later, I will demonstrate how to deploy a Kubernetes cluster. I run the command kubectl get nodes. I have a cluster with one master and two worker nodes. If I run kubectl dash dash help, I have an option with the kubectl API resources. Say kubectl API resources, it's going to show you all of the different resources that you can create in Kubernetes, such as pods, secrets, services, deployments, stateful sets. There are a lot of different resources that can be created in Kubernetes. The point I'm trying to make is you don't need to remember what are the various resources that you can create. You just need to ask kubectl, hey, get me the list of API resources that I can create. It will give you the list of it. And there's also shortcuts for these API resources, or short names is what I have to say. For example, if I want to know the list of pods, I generally say kubectl get pods. Alternatively, I can also say kubectl get PO. Same way, instead of services, I can say SVC. Let's do that. If I say kubectl get pods, right now there's one pod running. Now, what if I say get PO? It get you the same result, right? Same way, I can say kubectl get service, show me the services, or get SVC. So it also has some short names to use. Now, Naushad, you've been saying what pod is. Can I also take the help of kubectl to know what pod is? Yes, of course. You can ask kubectl, hey, kubectl, explain what pod is. So it's going to explain you. Pod is a collection of containers that can run on a host. This resource is created by a client and scheduled on host of the Kubernetes cluster. There you go. Kubernetes is a kind of, the pod is a kind of a pod resource which uses the API version v1. And when you create a YAML or JSON, these are some of the fields that you would need for that particular kind of a resource to be created within the Kubernetes cluster. Not to worry, I'll make you familiar with all of these commands. So it is the kubectl command, which is the basic utility in Kubernetes for you to manage your Kubernetes cluster. Some of the commands which I just used, kubectl get pods, kubectl get nodes. Get pods is to list pods. Get nodes is to list all of the minions or worker nodes that you have in the Kubernetes cluster. I'm sure you paid attention. Otherwise, I can show you that again. Kubectl get nodes. In Kubernetes cluster, you have servers which are master and worker node. Mostly, master is to manage the cluster. Worker nodes are to run the applications or resources within Kubernetes cluster. So in Kubernetes, we mostly use YAML for configuration information, which needs to be supplied to kubectl command or to the kube API server for creating the resources. It can be JSON also, but mostly we use the YAML. YAML stands for ain't markup language. It depends whom you're asking. Some says yet another markup language. That's absolutely fine. So YAML basically a readable text-based format file which will be used for specifying the configuration type of information. Mostly Kubernetes, software-defined networking solutions, software-defined storage solutions, OpenStack, OpenShift, all they use YAML. So YAML is heavily extensively used for configuration type of information. Every YAML file must end either with .yml or YAML extension. Of course, Linux doesn't need an extension, but extensions are to help ourselves. YAML is case sensitive. As the Linux is, the YAML is also case sensitive. YAML does not allow you to use the tab for the indentation. Instead, you'll have to use two spaces. The list members are denoted by a leading hyphen, and associated arrays are represented using the colon space in the form of key space value. This is some of the basic rules that you need to know when you deal with the YAML. I'm going to make you familiar with this, some of the basic rules. Why would somebody use YAML in Kubernetes? Because YAML provides a convenience so that you will no longer have to add all of your parameters into the command line. For example, if I need to create a pod, I just have to say kubectl run a pod by the name web02 using an image nginx. So it's going to create a pod for me to have the nginx based application deployed on one of the node of the Kubernetes cluster. To see whether this pod is created or application is deployed, I will have to run the command kubectl get pods. So the pod is getting created. Of course, I can put into watch so that I can keep eye on while the container or the pod is getting created. Yeah, within a less than a 1 minute time, you have your application deployed. So this command just giving you whether the pod or an application is created. It is, and it is in the running state. Or if I want to know on which node of the Kubernetes cluster it is running, dash O wide. As you can see, the Kubernetes scheduled the nginx based application to run on one of the node, which is kube node 1. Let's do a curl to a nginx based application IP address. There you go. You're able to access your nginx based web application. It did not take it did not took even a minute of time. Within a less than a minute of time, you have your nginx based application up and running. So that was the imperative method of how I created the resource. That's what I wanted to actually demonstrate. The command that I ran was kubectl run the name of the pod, the dash dash image and the image to be used for that. This is called imperative method. The declarative method of creating the application or a pod in Kubernetes is, let's call it as vim web03 dot YAML or YML. In this, you will need to have the pod manifest or configuration information, such as what is the API version of resource you want to create? What kind of resource are you creating? What is the metadata, meaning property of that resource, such as name of that resource, specification of the resource, is start to say spec. In that pod, how many containers do you want to have? And what are the names of those containers? What image do you want to use? The name of the image. Let's save this. This is how you need to write your pod manifest or configuration information. Now you wonder, hey Naushad, you remember this details, but how do we know these details? Actually, you don't need to memorize. Let me simplify this. If I ask kubectl, explain pod, it says the pod is a kind of a pod. So I have the kind, the API version. Okay, this is the fields that you need. First field is API version. So I know what API version the resource is. Then you need to put in the kind. I know what kind of resource is this. Then you need to put in the metadata. Metadata is nothing but the data about the resource that you're creating, such as name, label, namespace, and then the specification. What do you want that part to have, such as containers? So this feels like AKMS is one other way how you can remember, but these fields you don't need to remember. You can reference the YAML. That's one method. The other method is, let's do a kubectl run with the name web03 and use the image nginx. Do a dash dash try dash run is equal to client to confirm if this resource can be created. It says it can be created. Additionally, use the option dash o YAML. That means you're asking, hey, give me the YAML output of that. There you go. This is what you wanted, isn't it? So you don't need to remember. Okay. I can also save this output into one of the file. For example, pod1.yaml and open that file. There you go. You have those lines available and remove the unwanted lines such as you don't need that. And yeah, so you don't need to remember the YAML information. Okay, you see that I have made a typo here. Then be a space here. But what if I made some mistake? Okay, let me also show you that. Now, if I say kubectl create this resource and I want to do a dry run. Sorry, I should be saying dash F. You see, it says error while validating this YAML file. Okay. There is unknown field metadata. I have made a typo in the metadata. If you, okay, let's first correct that. Let me VIM. I made a typo here, metadata. And let's understand whether it will notify the other errors. No. Let's remove the dry run. and try to create a resource. It's been created. It did not bother even because it's a child resource. It did not bother for me to have that right indentation. But there was a typo in the metadata. So dry run helps validate your syntax. So you don't have to actually remember anything. You just need to learn the art, how to get your things correct, or how to help yourself within the Linux operating system, even when it comes to Kubernetes. So I just created a resource using the declarative method. Whenever we refer the YAML or JSON, how do I get the JSON? So instead of saying give me the YAML, I can just say what? Give me the JSON format. And I can save the JSON file, maybe pod1.json, right? JSON, right? That is doable. Now when I do a cat of pod1 JSON, I have the JSON file. I don't need to be master in JSON, right? I'm going to make your concept clear and easier to learn. So maintenance. YAML files can be added to source control system tools such as Git so that you can track those changes. I mean GitHub or any version control softwares so that you can track the changes. So YAML provides you the flexibility. You will be able to create much more complex structure using the YAML rather than having it written everything to a command line, which is why Kubernetes uses YAML. That's the first section where I just introduced you what is Kubernetes.